This lesson is about specific heat capacity, and by the end of this lesson you should understand how things heat up. You'll find out about heating water and also a little bit more about specific heat capacity. But before we begin, think about what would happen if I got a very, very hot nickel ball and put it into a beaker of cold water. Pause the video now and then I'll come back and show you what happens. So what you saw in that brief video was that the heat energy from the nickel had been transferred into the water, and so much so that it actually boiled the water. And we can see from this graph what's happening. So when there's a difference in energy, a difference in thermal energy, then it will continue to transfer. So it will transfer from the hot object to the cold object until both objects are at the same temperature. And so that's what that would look like on a graph. And we can actually look at this quantitatively, and we can look at the amount of energy that something stores by using specific heat capacity and the specific heat capacity equation. So let's look in more detail about what specific heat capacity actually is. So the specific heat capacity of something tells us how much energy is needed to change the temperature of 1 kilogram of a material by 1 degree. So the more material you have, the more massive something has, the more energy it's going to use to heat up. The higher you heat it, so the higher the temperature goes, the bigger the temperature change, is also going to take more energy. Now, different materials need different amounts of energy in order to change their temperature. So if you think about a typical summer day, you know instinctively that it's the same amount of energy from the sun which is going to the sand and the water. And yet the sand can feel extremely hot given the same amount of energy as the water, which still feels extremely cold. And the reason for this is because of how much energy it takes to raise the temperature, so the specific heat capacity of water and sand. Sand has a very low specific heat capacity, so it takes very much less energy to change its temperature, to raise its temperature by 1 degree than it does water. We say water has a high specific heat capacity, and that's because it takes a lot more energy to change 1 kilogram of water by 1 degree. So for the same amount of energy, the sand would rise in temperature much more than the water. This is the same for cooling. So water will release a huge amount of energy for cooling down by 1 degree, whereas sand won't release as much energy because it has a lower heat capacity, specific heat capacity. So obviously there's an equation, and this equation is that the energy that's being transferred is equal to the mass times specific heat capacity times the temperature change. And that specific heat capacity is different for each material. And of course, let's look at the units. So any energy that's being transferred is going to be in joules, and the mass is always in kilograms. Specific heat capacity, the temperature is in degrees, and so the specific heat capacity is joules per kilogram degree. So pause the video now and make sure you've got that written down. You're going to need it for the next task. So specific heat capacity can also be an indication of how much energy is stored in a particular material. So as we said, water has a very high specific heat capacity, and that stores 4,200 joules per kilogram degree. Copper, on the other hand, has a very low specific heat capacity of 380 joules per kilogram degree. So basically what that means is if 1 kilogram of water drops by 1 degree, it would heat up 1 kilogram of copper by 11 degrees, and that's the difference in the amount of energy that each of those materials can store. So a very basic question here is the specific heat capacity of a kettle of water that's boiling. So they've given us the mass, and they've given us at 18 degrees. So that was the start temperature. And then they've asked us how much energy is needed to boil it. So the first thing you need to do is work out the temperature change so that you can add that to the equation. They've given us the specific heat capacity of water, which is 4,200 joules per kilogram degree. And so all you would do was work out the temperature change of 82 degrees, plug all of that information into the equation, and that will give you the amount of energy that is transferred in order for that water to boil. So pause the video now and have a little go at these three questions. They get a little bit harder as they go down, and there is some rearranging of the equations, so have a go at that first, and then I'll come back and show you how that's done. Okay, so the first question was a straightforward plug it in. So all we had to do was pick out what they've given us in the question. So they gave us a mass of 0.9 kilograms. They gave us a change in temperature, and that was from 150 was the end temperature, take away the initial temperature, gives us a change in temperature of 135 degrees. And they also gave us the specific heat capacity as 380 joules per kilogram degree. Checking that all of the units are correct, we then just plug that into the equation. So the energy transferred equaled the mass 0.9 times by specific heat capacity of 380 times by change in temperature of 135, which gives us 46,170 joules of energy. So question 2 is going to ask you to rearrange the equation. So we're going to have a look at that. So firstly, we're going to take what they've given us. So they gave us the energy transferred as 10 kilojoules. Now the first thing we need to do there is transfer that into joules. So that equals 10,000 joules. They then gave us the mass of 2 kilograms. They then gave us, we had the specific heat capacity from the previous question of 380 joules per kilogram degree. And this time they're asking us to find the temperature change. So how much did the temperature rise by? So we're going to use our triangle. Now you can still use a triangle even though it's got 4 components. So we're going to use a triangle like this. So we can use 3 times at the bottom. Remember, these are our times line, this is our divide line. So we know that energy equals the mass times specific heat capacity times the change in temperature. And so we can plug in here, we've got 10,000 joules is the energy. We were given a mass of 2 and a specific heat capacity of 380, and this was our question mark, and we know these are times. So we know this is our divide line, and as we always do, we cover up the one we don't want. We get 10,000 divided by, don't forget the brackets for the bottom section, 2 times 380, which gives us a temperature change of 13.2 degrees. So question 3, again we're going to pick out what they've given us. So they've given us the energy of 50 kilojoules, and again we know we need to transfer this into joules. So it's 50,000 joules. The mass was 5 kilograms. The change in temperature was the end temperature take away the initial temperature, which is a change in temperature of 40 degrees. Again, we're going to use the triangle to help us. So we quickly draw out our triangle. Energy equals mass times specific heat capacity times temperature change. And again, they've given us 50,000 joules of energy. They've given us 5 kilograms here. Specific heat capacity is the question, and the change in temperature is 40. So again, we know these are times. We're going to cover up this, which gives us 50,000 divided by, remember your brackets, 5 times 40. And if we plug that into the calculator, it gives us 250 joules per kilogram degree, and that's the specific heat capacity of that material. So that's a summary of the answers to those questions. Hopefully you got on well with that. So hopefully you now understand how things heat up, you understand a little bit more about heating the water, and you found out a lot more about specific heat capacity.